I think probably we should start by asking panelists to have some, sort of striking thoughts that they got by listening to the others and any questions for the others. And then we'll go into more specifics. We have some questions. I have some questions, some thoughts, and so forth. So, what do you guys take out of this? Is everybody convinced, and how is all related to what needs to be solved in real world and so forth? Scott, you were very excited about implementation, so maybe I pick on you first.
Sure, Maria, I'm happy to be picked on first. So I'm trying to gather my thoughts. So let me organize into maybe 3 thoughts. The first one is I am really inspired by the excellent research being done, by everyone we've heard from today, and also through the Q&A, right? People were listening and providing thoughts and ideas. It's really, really fantastic. And I think it justifies the workshops like this where we can get together and really talk and share ideas, because a lot of us are thinking along the same lines in terms of problems and methodologies. I honestly did not expect so much overlap. That's item number 1. Item number 2 is, in spite of our intellectual prowess on modeling, optimization, AI, algorithms, there's a lot of questions that kind of bleed into human behavior, policy, and I think this is not something I've personally been trained in, and I think in the beginning of my career I maybe avoided, but I think if we are to not just write nice PDFs on servers, but to actually make positive impact, thinking about these questions increasingly, how to make this practical, what are privacy considerations like Christine was talking about, how will markets, dictate how these, demand response mechanisms can apply. I think more can be done, and we should work with our colleagues who are experts in policy. Okay, I'll pause there.
So thank you, Scott. Just to build on that a little bit, the thought that struck me was, okay, is the problem now, there are a lot of people, young people like some of you guys working on the demand side, on the edge technologies and so forth, but there is very little adoption. And I don't think, this is just my personal take, I don't think it's just about policy. It is about how we reintegrate. How do you put the tools that Louis is talking about? There is a system operator who worries about reliability. And then Christine comes and says, oh, my demand can do this. So how do you put it together so that, Christine, you talk a little bit about the congestion and making sure that things are feasible in the use, power flow wise and so forth. But those are constraints, right? So at the end, you check if it's feasible. And so it sort of lose that machine learning take at the end. The hard constraint, the reliability guy is at least the way, has been so far, except for some of the Louis work, is been, you just do hard constraint, I do static power flow and so forth. And then if something that end users, unconventional end users want to put on the system is offered, there are no protocols, I would say. I'm not talking, Scott, about policy that much. I'm talking about technical protocols for integrating some of those technologies. And just to give you an example on the bulk power system, for example, I don't know how many of you are familiar with, but automatic generation control has a very simple protocol. Every utility balances itself and then the frequency is fine, right? So do you have any thoughts on some minimum information that must be exchanged between different layers so that at the end of the day, whoever is responsible for reliable operation actually accepts these technologies? just a question, general question, and in that direction, if people have thoughts.
Yeah.
Okay. All right. So basically, we are developing. Okay. One more question there. As you guys were talking about, and Lena and others have heard me before saying, oh, yeah, this is a sort of machine learning version of how to create bids. But, people have designed bidding techniques for demand. And, there's a lot of state-of-art things for adaptive load management and things like that, right? So are you saying altogether at the end that without machine learning, this is not going to work? What is the relationship between the more conventional state of art on the decision making and the edge technologies compared to, like, in energy markets, the demand bids and disaggregation, Christine, that you're talking about? That's how bids are created by aggregators, right? They don't tell you everything, but they tell you how much power at what price I want to buy, right? So these very difficult links between what's happening in energy markets, in electricity markets, in the actual operation, and what machine learning can offer. What is the magic?
May I intervene?
Yeah, please, Louis. Yes. Yeah, everybody. Yeah. Mm-hmm.
Yeah, I think keep the human in the loop is a very important thing. Because, I mean, even with the classical approaches, in the end, it was let's say, the engineers or even the policymakers at some stage that took the responsibility of deciding how to, let's say, to evolve the system to adapt to new problems or new opportunities. I don't think we can avoid this. And actually, we should not try to avoid it. We should try to foster it. We should try to, let's say, to do all we can. And machine learning, I think, is actually a possibility to help human experts, human decision makers, to better understand what are the stakes. Because you can look at the data from different perspectives. Of course, you can say, oh, I have let's say, an optimization problem, and I just want to maximize my reward. But you collect all these data, and it can be used in much more, let's say, diverse ways. In combination, I think, with the I mean, I always come back to that with the physical models and the understanding of the physical. And when I say physical, I should say first principle rather than physical, because it's not only the physics, it's what we already understand about the system that we should really try to find a way to, let's say, to couple with what we can learn from the data.
So the other question that was raised by a person in the chat, but it's very related, is to what you were saying, Louis. I think this problem, viewed from the system level, from the grid level, it's so combinatorial that exploring, really finding the right combinations, doing the right, risk functions, and coming up online or a little bit ahead of time with right information about what's likely to happen, really becomes very complex. So one way, and I think that's what I heard Christine talk, and I think it's in all of, Scott, Lena, and it's that a lot of intelligence, a lot of decision making happens at the edge, at the end users, and we make it a little simpler now when we coordinate all of that. So do we have hope to go to let's say, to Ontario Hydro or Hydro-Quebec, Christine, and tell them that, okay, it's the other side of Canada, but anyway, to go and tell them, if you integrate all the way down from the distribution system, it'll be simple enough so that it's transparent how it affects the reliability and so forth. I think the combinatorial aspect and scalability is a very serious issue.
Yeah, absolutely. I think I agree with all the comments that there's somehow, this interplay of the centralized entity versus the edge devices. And somehow, this is not going to be like tomorrow, we flip a switch and it's just going to change. So there is some like baby steps that we need to take in between. And I feel like, with the kind of, coming from a power system background, I do feel like there is problems that we may not be able to solve very well based on a physical model. So for example, the behavior of a customer, right? What they feel is uncomfortable to them, right? And everybody has a different, background and depending on what they like or dislike, right? It's totally different. And so there, I think the uncertainty in that is really well catered, I think, to a machine learning algorithm or a machine learning technique. Whereas, you still have the standard tools, optimal power flow, for example, that ensures that the end result or the power system is still running with the level of reliability that we've come to just, take for granted in some sense. Yeah.
So the other thing, it's early on when Lina, you were talking, and Scott afterwards, I think the same. And even Markov process that you're talking about, Christine, in power systems, if you think about load demand, let's say over one day, or one day is, let's say, one time horizon. But if you think about how load changes, system load changes, there are several periodicities, right? And so when you do this learning, what is important? For EV charging, is it more important to predict for a month ahead, or you do the learning just an hour ahead, or you just take what Scott told you, just do flex and you will be fine. So Lina, also in your models, you have these Markov decision models, but they are very different. If you do the decomposition of the load, uses Fourier transform or whatever you want to do, the load in June is very different. June, first week in June is much different than load in September, for example. So how do you guys in your methods take into consideration the periodicity of the load? Do you have several families of loads, or what are you doing in these edge technologies?
Okay, thank you, Maria, for the question. So I will answer this question first, and then probably also go back to comment some question regarding the bigger picture. For the setting, we have been putting, like, for the learning, like, we look into the data and we really try to understand, so the time variant pattern, indeed we will see it. So that's why we go with the online learning, means we're updating the model all the time. And there are different kind of time scale issues, even for that level. For the load, so different load, they can have a different model, and depending on the different season, it's also different. But then, taking the AC model as example, a few days of data is good enough for me to predict what the relation between the room temperature, outside temperature, and also the power consumption. So in that way, what we did in reality is we do the online learning all the time. Is each time you do the receding horizon using the latest information to update, because people's household information will also change. Sometimes guests coming, and sometimes it's just one person inside the room. That's also change the thermodynamic model. So that's what we are trying to say. We should keep the learning model simple enough, then we can just using the latest data to update. So that's for that part. And then the other component, so this is for the electrical devices, and the human part is more complex. And the human part, even for right now, based on our data study, we observe some pattern that's consistent over the summer, but there's also some other behave is very like strange. Like sometimes we turn off the target temperature be a very higher point, and people stay in. And sometimes the same person, and then when I'm making the target temperature lower, the person opt out. So there's something going on like in the background that we don't know. So that's kind of related to the question you were asking about if we eventually what's the how to map all the different layers of the operation in the power system. Like honestly, I still think for the especially for the residential demand response. So the stage we are at right now is still at the like the pilot study to understand the potential of the residential users. Because as a like system operator, I don't like seriously, I don't really like the additional uncertainty come from the like the operation. If you told me you can like reduce certain amount of load, as like the one aggregator come to tell me you can reduce as much of load, I really hope you can kind of keep like the accuracy with certain range, right? If a lot of people opt out, that's kind of disaster for my system operation. So right now, like based on my experience working with the industry, so even at the utility company level, so they want to understand like how much budget they really need to budget for the customer. And they have like, I think a few years ago, we're talking about if we can make each agent, each user just like 50%, like $50 over the summer. So that can be sustainable. If it's more expensive, they need to rethink, should I go with some other reliability services rather than the demand response? But then within the $50, how much we can really have, what's the maximum load reduction? And how much uncertainty, or like can we control the uncertainty? So we are still at that stage. And those things will relate to the method we are developing. So we are actually trying different kind of method every year to see the outcome. And hopefully with more and more data, right now we have more and more users enrolled in the program. Based on the feedback, we can roughly know if I want to retrieve certain reliability, and that's how much like buffer we can provide. If I'm going to bid into the market, I'm not going to bid too much. So that's kind of the study, in my opinion, for the, at least for the residential user side. And then for the machine learning, then it's even a bigger question, which part we should do the learning, which part we should do the model base and using the knowledge we had before. Even for the residential one, as you can see from my talk, we kind of pushing the way of thinking, right? Try to calculate that for this part, I can do the learning. And for the other part, I can just using the like OPF scheduling to taking care of it. So we're still following this kind of big framework to do it. But how much we can push is still like, we'll wait for the future years to see.
So just to put things in context, this is a story from California, Scott, when the electricity market, let's say phase 2 was designed. Ralph Maciello was working for ABB. They were trying to fix the California market. And there was this big issue about the difference between net system demand predicted by CalISO versus what the aggregators, PG&E and Southern Cal Edison are offering. There was the difference of 20–30%. They were not correlated at all. So I think what we are talking about here is it's different level of spatial granularity, temporal granularity. 3 of you are down to distribution level, and the aggregate effect of those and so forth, that somehow has to be mapped into relating it to what the net system demand is. Everybody was showing that curve, but if you just, on whatever system, if you try to relate the two, you will see that the data is very, very unrelated. And that is a huge issue on how accurately who in the supply chain actually estimates the load, because this was a horror story when I was a grad student. EIA had Energy Information Administration had a paper in which they say that they do all these predictions for what the generation should be, what is the demand and so forth between different utilities. Do you know how they said that they estimated the load in control area? By subtracting generation from tie line flows. There was no relationship. There was no data from the load side. Okay, now we are coming with all these methods and say, if you squeeze everything on the load side, and probably you can save a lot, as we see in your presentations, but the two somehow have to be related to the methods. How is the system demand being predicted? And as you see, it's a very long path. Louis was doing his AI. This is why I was so excited about your talk, Louis, because, the people were taking the, machine learning for contingencies, that it was described as a real opportunity many years ago. But 30 years after that, you turn around, and I think maybe Hydro-Quebec is using some of that. I forgot who is using it, but not many utilities are using. So it almost looks like if you start putting these stations, with flexible, with coaching the EVs or clusters of EVs what to do, or demand side neighborhoods, that we are going to come at this problem in a very different way on how to manage the demand. So I think it really raises the question about what type of models we use for which level of power system. And so it is, we all get excited about our own, methods at different levels, but I think that we should also be thinking about how to align the information between the different layers in a semi-accurate way. Otherwise, just basically there is no connection right now between, there is very little adoption on the demand response. And there is a question on the table, why not? Right. Okay, so that was on that. So let's see, maybe we can, Scott, do you want to do yours on that you wanted to talk about energy justice? We can maybe do that one, just a little bit of orthogonal discussion, and to go through the questions that people have, right?
Yeah, sure. So, yeah, with this question, I'm quite honestly going to channel Professor Destiny Knock at Carnegie Mellon, who's certainly gotten me thinking about these issues. Maybe I'll pose to my fellow panelists this question. So when we're talking about demand response and aggregating demand response, we're largely talking about people who can spend $50,000 on an EV, or people who can spend $250 on a smart thermostat, and we gather data on their loads and we say, okay, what if you reduce, for example, it's hot and we want to reduce their temperature set point or increase their temperature set point from 70 degrees Fahrenheit to 72 degrees Fahrenheit. Meanwhile, there's this large population that doesn't even purchase air conditioners because they can't afford, it's too large a part of their income. And, they're not part of this at all. But if we could tell them, we'll give you air conditioning for free, but if you can be responsive in a demand response program, right? So, and they may be more flexible, right? Because they're more used to living in a situation without energy. It could be even a bigger resource that's available. So, and it strikes what I was saying before about, we can acquire flexible resources, yet address issues of energy justice at the same time, right? So I wonder, how can we do this, right? How can we support this type of effort? Because it means getting data where data is hard, and it means working with communities that we might not traditionally work with. So I'm curious how you might think about this.
Does anybody have comments, ideas on this? So one thing that I see at the university didn't used to be the case, and that's why things were moving slowly, but a lot of people are talking about having digital twins where we emulate things and show what it is and what it might become and what are the potential benefits. So it's probably worthwhile thinking about the role of university in catalyzing this innovation, including energy justice and everything. So, you do a lot of, we don't have good emulators of what happens on the system, depending on if you do this or that, but, on real time. And people are beginning to talk very, very seriously about digital twins, maybe more in context of we have power electronics and things can go unstable, but also at the level of integrating all these technologies for sustainability and for resiliency. I think that universities could play quite proactive role in teaching, demonstrating, because some of these things are very complex, honestly speaking, right? You go and tell people and they can, nod their head and say, yeah, I believe you or I don't. But if we have visualization and real convincing demonstrations of, let's say, if you had this portion of at these locations in California, these users doing something, look, the duck curve would look something like different and everybody would benefit, and these would be the impacts on different stakeholders. I think that as universities, we are not doing much on that. So there is I'll say something that maybe will backfire, but I'm okay, I can do that. There is a lot of economics, environmental studies, which basically say, yeah, if I put so much storage, I can cut the peak of the demand and so forth. I think we need the level of detail which shows how some of these smart techniques, what is the value of adaptation and looking forward and machine learning on the system doing better. Very little of that, I think. So are you guys working at your universities with students on demonstrating some of that, or where do we take it beyond just, okay, here is the method?
May I just comment on what you said?
Yeah, please. Mm-hmm.
So I don't want to be the old guy who is negative and
it's okay.
Here.
There's some of us old.
What I think, what you said is very important, and when we talk about energy justice and so on, these are super important things. And we could, of course, broaden them to the climate and all other kinds of current, let's say, problems that kind of stimulate questioning of the society. But I think it's essentially a question of how do we make sure that we share the benefits of whatever, let's say, positive development is made in such a way that it keeps the, let's say, those people who will be able in the future, not only for the current, but in the future to participate in making other positive moves. So it's a kind of, the danger in my mind is that we reach a situation where people say, okay, forget about it. Anyhow, I will be the end loser all the time. And I'm afraid. So therefore I said it's a political or maybe a bit negative viewpoint, but I'm afraid this proportion of people who think like that is growing. And so I think it's actually one of the main problems is that we need to think about how to get people in the, let's say, in the venture. And for that, I think we need to really think about how to share the rewards quickly with them.
Does that make sense, Scott, to you?
Yeah, I think so. And
what would you do? What would you do? What's your dream on this energy justice? I mean, you keep bringing it up. What would you do? Yeah.
Can I weigh in this discussion?
Sure. Yeah.
I like Scott's question, and that actually reminds me of the conversation we have here at Cambridge and Boston. So one was trying to talk to our accessibility office about the DR, like the AC we've been doing, and they were so excited. And they also putting me into talking to the Cambridge office. So why they care about it is this. So right now, every summer is getting hotter and hotter, even at Boston. And so people really worry about for the like low-income family, they cannot afford AC. And for the climate change, there are the people who are going to suffer more. So can we do anything? So the city, at least here, they have initiative to tackle these issues. And we, like just last year got in disrupted by the pandemic. So we were hoping to resume the conversation. So there's a one. And another for the EV, we had a conversation with people from professors from public health. So what they are worried about is, so right now, like I buy the EV, I have an EV, and like for the people, they can just charge at home, charge in the like company. Again, for the low-income family, they don't have a parking lot. So, and in the future, if say, hey, everyone has an EV, and like even for me, I buy the second used car. So probably all the second used car is going to be EV, and I bought the EV car. Why am I going to charge it? And that's also an issue. So at least I think here, the people in public health, they were thinking about from the infrastructure, right? If we want here, like if we really want the EV going to be adopted by a larger population, we need to figure out the charging situation, like for the home charging, where the people can charge in their local neighborhood that they don't have parking lot, and how the charging station should look like. So I don't have an answer for those, Scott. Like I do think those issues are important, and people are studying, working on it. It's not just like people from power engineering, the people from the policy and the public health, they also look in this problem. So I like you raise this point.
So just one thought there. So what do you guys think is better, to do a lot of distributed demand response with a lot of smarts, or build a utility scale large clean resource? There are economies of scale, and building many small ones with a lot of expensive infrastructure has to be compared somehow to the way utilities think about this. They are going to build a couple of very large clean wind power plants and utility level storage. And do we have a case to show that many small ones with embedded machine learning would really outdo what large scale investments are in clean resources, including storage, large scale storage?
And again, if I may just come into the, I think to answer such a question, you have to define the scope, I mean, the geographical scope of your question. So if you pose it at the global level of the whole, let's say, humanity, it's a bit different than if you pose it at, let's say, the level of some, let's say, Belgian or Massachusetts or Californian economy. And so I think we can get different answers which might not be in full contradiction, but which I think it's very important to coordinate, I mean, to make sure that they are not in contradiction.
Right. So
I think the real problem is global. It's not really a local. I mean, we can procrastinate and say, okay, provided that we do things nicely in the next 20 years, it will be nice for us. But
so what I'm talking about is a method, not necessarily that you'll come out with the same answer for every utility or every country, but how do we open these? Sometimes they refer to as non-transmission solutions. Anything else than just building, a lot of transmission from Wyoming to large control center, to large centers, load centers, so that you supply these unconditionally. That's one way. But there are all these non-transmission solutions that we are talking about, and the methods of comparing them, but really comparing them like apples to apples, are missing, I think. Because going back to why are things not happening, if you make the case and demonstrate in your, nice lab with visualization that, look, this is how much better it is. Bring the local utility, show, bring different stakeholders and educate. I think, honestly, I think we have, I don't know how it's exactly in Europe, Louis, now, but we have really fallen behind with that, with leading in, what would be different solutions. We don't even have a way of evaluating value of software. When you go to the utility will build the transmission line, will build a new gadget, it will build a large-scale storage. But when it comes to saying, okay, build in security constraint, optimal power flow, oh, by the way, should be also machine learning, there is no way of evaluating that systematically against something else. And so we owe ourselves, I think, in particular, as we are trying to emphasize here, the potential role of machine learning on how do we demonstrate these potential values and then go to policymakers and educate. Without that, I think nothing is going to happen. Or like Scott, you build these, I forget how many things at University of California at Berkeley in some garage. You show that these work. I think Steve Law did another thing in Caltech, he has another thing there. Okay, is this are we pursuing this by, sort of grassroots, building slowly and defecting from the grid, or what are we doing? Why?
Yeah, so maybe, so a comment on kind of related to that, but also the education piece, which I think is really important. So going back to my example of Toronto's Peak Shaver program. So this was a program, multi-year, I'm sure millions of dollars was spent on it. And, to advertise it, market it, et cetera, et cetera. And again, only a handful of times it was ever triggered. So a lot of criticism for that, right, in Ontario, that, the government wasted so much money on something that was never used, didn't, have any effect whatsoever. But I really don't want to discount the educational effect of this effort, because it really got people thinking about their electricity usage, talking about it, right? So my parents, they live in Toronto, and I went home for one Christmas and they were telling me about how they need to now start doing their dryer in the middle of the night because that will save them money. So, these conversations are not, they're not trivial, right? They need some kind of, instigator from, either the government or the utility in our case, I guess, to really start these conversations and to make them everyday part of our lives.
So Christine, you were talking, I think, about peak shaving with direct load control, right?
Yeah.
Experiment. So there was similar experiment. I was told this before I moved to New England, like in the 80s. New England Electric, which now became something else, but they did a lot of demand response experiments with EPRI. And at the end, it was all direct load control, right? With similar motivation that you described. And at the end, what happens is that not every electron has the same value to the end user. So we have to get this information, it cannot be direct load control because you have to somehow balance this. A lot of you were showing the trade-off between your expected comfort and expected electricity bill. And that can be automated through the intelligence inside the demand, or it can be at the aggregator level. But it has to take into consideration that this direct load control is basically just when utility worries about not having enough supply to meet the demand or cannot deliver because of congestion. But they don't take into consideration, I would not say necessarily load criticality, but sort of different types of loads that if you were to shed, you would have to shed it according to the needs of customers. And so I don't know what was done exactly in Toronto, but these two things have to come together, because everything that you were talking about is I am already trading, how much am I paying versus what it does for me. I listen to all three, it's just different technologies, but at the same time, it is not clear how does that relate to, how does it compare to if you were to just do direct load control in California, which I'm almost sure that, CAISO is trying to do, that when there is shortage, I think just yesterday they said it's too hot weather, so you guys are supposed to cut back. And so that's a little bit of customers' behavior, but at the same time, different, if the customers don't respond, then nothing happens, right? And you still go into brownouts. In the 80s, that was in New England was triggered by hot summers where they had to do the rotating brownouts because of voltage problems. And utilities tried their best. There was distribution automation and demand response and everything, and it stopped. It came to full stop. So I think so many years after that, we are really trying to do this, but this is why I think that intelligence and communications, which take into account different types of customers and needs and trade-offs with their what they want to pay, I think that has to be some sort of multi-directional information exchange rather than just. I think what I heard you, Christine, I heard you a little bit talking about both levels, but. Scott and Lena, you were just sitting in the customer's shoes and saying, I can do my best here. And you have to trade that against, what is the utility going to charge you versus what's worth to you to be flex and so forth. So I think that this reintegration of balancing the system with distributed energy resources is going to be a big issue. And I have a big problem when somebody says, yeah, this is actually just policy question. At that point, we lose it completely because the policy is not looking into the level of detail that we are talking about. So going back to how do you connect, what level of detail you need to have in the policy in order to catalyze some of these integration of these resources. I think there is a disconnect, at least in the communities that I know, between policy people saying it's capacity-based thinking versus here we have flexibility and so forth. So how do you put the two together? I think it's another thing that needs to be looked into. And so I think let me just try, because we are almost coming close to the end, but there were some other questions and maybe we can just very quickly go. There were not that many, so let me make sure that. So the question was, what is the hardware requirement for centralizing or federating control? I think this was, Christine, for you, of all these controllable loads. Does this require an overhaul of distribution networks, requiring everyone to download the same software and have a building operating system, or can it be imputed more seamlessly? It's sort of related to what we've been discussing. So I think that was a question, I believe, for you, Christine. I'm not sure.
Yeah, I believe so, based on the timing of it.
Okay.
Yeah, certainly it's a challenge, right? I totally agree. And to Scott's point about energy justice and these devices, how much would it cost to build something or to buy something like that? So point well taken, I would say. And I'm honestly, I don't have a good sense of, the cost of the hardware that's involved with doing this, unfortunately. I don't know if other.
The other thing is, I've talked a lot to utility people and Louis over time. Louis, I think when you start talking about the type of stuff we are talking about today, there is this sort of inherent question about complexity. If you want to bring any new software or you want to bring new functionality, that's a sort of threat to the conventional way of doing reliability. And I think it's very real, actually. The bulk power systems people. Historically, it's taken. I was told it takes like 10 years to upgrade some software at the bulk power system level. If you are going to do this reintegration, we are going to have to do that. And so, this is a question very dear to my heart, so I'm going to bring it up. Most of the software that utilities and system operators use, they are done by 2-3 vendors, right? And they're monopolies. Do you see room for startups, for new developers who would like implement software for your Flex embedding into EVs or for your demand response and sort of catalyze the evolution of software? Have you guys thought about that a little bit? Because otherwise it's going to be business as usual. You know, it all works. The lights on.
My answer is yes.
So elaborate on that.
Because I think that more and more you can do at the, let's say, the lower level. So by acting, let's start from the, let's say, the home automation system, and then go up to the microgrid, and then go up to the small distribution pocket, and so on. There lots of things can be done there, and start to make some sense from an economic point of view. And so even if, let's say, the established operators for whom I've, let's say, kind of done my research for many years are not able for, I mean, I'm not saying even they are not willing, but they are, let's say, in a situation where they are kind of frozen in terms of ability to innovate. I think the push will come from the, let's say, the lower parts. Now, I think I wanted to put one, that is one consideration here, is that so you can think of lots of small companies or big actors like we have in other sectors like Google and Facebook and so on. Because I think there is really a question of learning of how to work correctly at this, I mean, from the bottom up. And this is, let's say, a topic where data is going to be super important, of course, but also the possibility, beyond passively collecting data, to do small-scale experiments that can be kind of transposed, you know. I mean, you have 1 million customers. You can, with maybe 1,000 of them or 10,000 of them, make some experiments to understand what are the preferences in general of the customers. And you pay, I mean, you can pay for that just because you think the value of collecting this data will allow you to more broadly, let's say, optimize your relationship with a bit much bigger set of customers. And so this is the idea, I think, which exists in other fields of, let's say, when you have a large number of human, let's say, interactors, to do some small scale experiments which will not jeopardize the whole portfolio, but allow you to learn. So I think this is a part, so it's not just using the data that comes, but thinking about how to gather, how to generate interesting data.
This is really the opportunity for machine learning. I agree 100% with, and now utilities will let you connect if you're under, I don't know, in Massachusetts, if you're under 20 megawatts or something. But when it comes to aggregators, to larger load serving entities connecting, then they have to do these 1-year studies, interconnection studies and so forth, and sort of slows down any integration. So how do we develop machine learning at that level, when from the aggregators, sort of medium voltage distribution level connecting to transmission? I think that machine learning probably can do quite a bit there to help. And I want to just mention one thing, that I agree, Louis, with what you said about gradual learning and expanding bottom up. But I was involved in a DHS study for Lincoln Lab on architectures for Puerto Rico. They had a lot of hurricanes, and the question was, can you operate the Puerto Rico grid in the future better when you lose even 80% of transmission? That was the question on the table. And I learned a lot. We did something, but I also learned a lot from listening to other people. What's happening in Puerto Rico, you have small businesses, you have schools, different types of buildings already defecting from PREPA. Actually, right now, PREPA doesn't even exist. It's been taken over by some combination of Quanta Technology, I guess, and Alberta Power Company, Luma, I think they created. So this new company has to operate to provide service to Puerto Rico customers because the utility PREPA, the conventional utility, didn't do its job during the hurricanes. So I think the reason I'm talking about this is it may take some very extreme situations when people rethink. This is what's happening in Puerto Rico. Everybody, okay, they have sunshine, which is great. Everybody can put a little bit of their distributed resource. They're not talking that much about the demand, but they are beginning to understand that neighborhoods and smaller parts of the system within distribution can supply themselves resiliently. So we haven't talked, I think in this workshop, we haven't talked at all about machine learning for resiliency, but I think it's probably a very important one. And just putting it on the table for the record. And because people, you can either buy, dirty diesel backup generator, or you can do something nicer, in terms of whatever resource you have locally, distributed resource, adjust your demand as you need. And I think a lot of that will be taking place in developing countries where people just have little so much, and then they want to supply themselves, and the demand will adjust to what's available. So you don't have to even rely fully on the expensive storage, which is also another problem. So on the analytical side, we are almost coming to an end, but we didn't talk at all about, at one point, Louis, you mentioned about this multi-stage look-ahead decision-making, but even at the distribution level, sort of the fundamental role of model predictive control and how it gets combined with machine learning. Can you guys comment a little bit on what is the situation there? What do people know? Are they thinking about look-ahead, even, at the demand side locally? You predict, that's why we were asking about these different periodicities. If you do something for the next month, you may have a trade-off because you don't know everything for the entire month, but you want to adjust for whatever pattern you have. So model predictive control is, we've even written papers, it's a big cure even for the duck curve in California, because you can activate hydropower in time with very good prediction and then just correct with something else around it. So can you guys talk just a little bit about model predictive control and what needs to be done there from the machine learning side for this to work better?
I will start. So for our method, we actually also use the machine MPC, model predictive control, inside the method, because I think for the power system, the huge challenge is about uncertainty and the time very uncertainty, right? It's so difficult to predict for the next month, but it's okay to predict next few hours. So we actually keep that feature. And then the way to combine, like in my definition of learning is very broad, like anything related to data, we can call that the learning, not necessarily the deep learning or reinforcement learning. So like just based on the data where I can use the data to improve my model. If I already have the first principle model from the power engineering, I can just keep using that. But then for the user side, like this, like Krishna also talking about the uncertainty from the user's appliance. And for those one, if I don't have model available, then I can use the data to learn it. But even to learn it, I can follow the MPC, model predictive control principle to do it, right? Because the model is also time varying, there's some shifting. So the way, in my opinion, to make it successful is not just like do the pure model free, just go ahead to taking the entire machine learning method, right? Is like combined with the pioneering with the data plus MPC to do better receding horizon. And that's will lead to the question about that in the future, what kind of different time scale we should have from transmission level to distribution level, and at each layer, right? There's also spatial scale, and from that kind of level, what kind of information we should aggregate and put into the upper level decision. And each time for the MPC, we can always have a buffer to come back to renegotiate about decision we're going to do next. So that's kind of my opinion. It's going to be holistic, putting all the approaches inside, by trying to figure out which one is better for which component is the challenging. Yeah, thank you.
Thank you. I think my understanding, Louis, was that you did early on, maybe second stage of your development is look ahead at multi-stage, but it was at the system level more, at the utility level.
Yeah. I was thinking, and it's true, I'm focused on the, let's say, the transmission of the bulk system. So there it makes sense, I think, to spend a lot of time on having good models and let's say taking the best out of all kind of analytical techniques, even improving them specifically. Now, if you go to the lower, let's say the microgrid again example, I think it also makes sense to build on top of model predictive control, but you cannot have a good business case if you need somebody to maintain the model for that and spend a lot of time on it for each little house and for each little microgrid. So I think the idea would be to start with let's say something which is a rough model predictive control approach, on top of which you can use data gathered from the real system to refine it somehow.
And I think that's what Lena and Scott were talking about with your experiments, guys. So I think we're out of time, Alejandro, right? Almost out of time. And
yes, probably now a good time to wrap it up.
Yeah, so I just wanted to say that there were some other questions, and maybe if we can somehow, Larry, if we can somehow save them so that different panelists still address those questions to different people. I think I tried to cover in real time as much as I could, because some had similar things about combinatorial aspect, energy, justice, and so forth. So I don't know how much we covered, but there is a possibility if you have specific questions, send to us and we will connect you with the panelists, and all this is video recorded. So I can't thank enough to everybody. It's, it's so nice to see you guys. Louis, I have to speak for two of us, but it's so nice to see this young generation now doing things differently than we have done that for the, grid top-down things. And then again, just one take is that it is not going to work if you just do it at the distributed level. Somehow you have to put these two things together. And if we don't work to show how you do that, how you reintegrate, what should be the protocols, it may be a very long way before anybody pays attention to us. So let me close there, and thank you very much. It was wonderful. Can you share the slides, Alejandro? They need to upload slides, or what is the protocol?
They can send it to us, and then we can send them to Larry,
Okay.
so they get uploaded. But yeah, and I would like to echo Maria's comments that this was really great. I mean, the set of talks, not just today, but throughout the workshop, was fantastic, and it generated a lot of discussion. So I'm very happy on how it came together. So I cannot thank you enough, all of you.
And it will be all on YouTube. So if you have your colleagues who want to see it, and it's all available. So just disseminate. And I don't know, there won't be proceedings. It's just recording, right?
Yes, the recording. That's correct. Yes.
Thank you very much, guys. Have a
Thank
good
you
week.
all. Have a great weekend, and hopefully we'll see you in person soon.
Yes.
Yes,
Well,
hopefully.
that is a different question. Who knows when are we going to see each other in person?
Hopefully soon. Hopefully soon.
Yeah, I hope so too. Yeah.
Let's see.
Yeah.
Let's see.
Thank you for your time, everybody. Yeah.
Yeah.
Thank
Bye.
you very much.
Thank you all. Bye bye.
Thank you for
Bye, everyone. Thank you.